Hi Nicole, this is for 5-1 about the particle that's on the circle where the psi equals n sine alpha phi. This problem is an example of many types of problems in chemistry where you have to try different things, and even though you know you're going to be wrong, you have to just write your ideas down and work them out until you're sure that it's wrong, because it might be right. Here's what I mean. The phi here is said to be the position of the particle on the ring, and it's said to be, well, I'm going to draw the particle here instead. It's said to be the position because the particle is on the circle. So the only thing you need to know where on the circle is the angle from some origin that you just draw, wherever you want. So this is the angle phi, and this angle defines the whole position, all information about the position that you possibly need, because we know it's on the circle. We just don't know where on the circle, and the angle tells you where on the circle the particle is going to be. All right? Now, because the particle is on the circle, that also means that the psi for phi, like the psi for phi, has to be the same as the psi for phi plus 360, you know? So that has to be the same as the psi for phi plus 360 degrees. Or in math language, radians, phi plus 2 pi, all right? So that has to also be the same as 3 times around, phi plus 6 pi, or even 2 times around, phi plus 4 pi, or 4 times around, phi plus 8 pi. So these all have to be the same as just psi of phi, right? So then you're like, well, so how do we do that? You start with the easiest case, this first case, and then you just try a few things. So you just have to try. You know, some people, this is just obvious to them, and none of these tries are actually, at risk of being wrong. But for most of us, we don't know how to solve this, and so we just try something. I'm going to substitute psi right there. I'm going to substitute this in here, and then I'm going to substitute, instead of phi, I'm going to use phi plus 2 pi. Right? So put n sine, oops, I forgot the alpha. N sine alpha phi plus 2 pi. And then you're like, oh, how do we get this to equal that? I mean, I know that this equals phi in trig because it's just 2 pi here, but this alpha is in the way. Like, what about alpha times phi and alpha times 2 pi? I mean, what if alpha were 1/2? Then this would be just pi, and then it wouldn't be the same as, so phi plus pi is not the same as phi plus 2 pi, or not the same as phi. So what do we do about that? Well, this looks like distribution, so let's distribute it. You don't know, or most of us don't know, that this is going to result in something good, but we just try it. The sign of all this distributed. We just try it. And you're like, that looks ugly. And you go, n sine alpha phi. Now things are looking ugly. And you do not give up. You just go, okay, let's make it less ugly. Divide everything by n, and then it's less ugly now. So sine alpha phi, does that equal sine alpha phi plus 2 alpha pi? Well, it would if this were equal to 0. So alpha, we know, could equal 0. That's a possibility. But in science, it's very often the case that alpha that some constant equals 0, and that's usually not the interesting case. So we know that alpha can equal 0, but what else can it equal? We call this, when the constant equals 0, we call it the trivial case. So what about the other cases? Can we massage this, change its form a little bit? Well, I don't know. Let's just try something. You just try stuff. Just go, well, this looks like an addition formula, and in the problem, oh, sorry, that was the wrong page. Yeah. So in the problem, they have this trig identity here for us to look at right there. So let's try another trig identity. This one where it goes sine alpha plus beta equals sine alpha cos beta plus cos alpha sine beta. You remember that one? Well, you're going to have to remember that one. I didn't remember that one. Actually, I found that on Google. So this is something plus something, and the sine of something plus something equals this. And then you go, all right, so what was the... so unfortunately, I used alpha here. So this is the alpha, and this is the beta in the case of this formula. All right, so it's the sine of the first thing, alpha phi, times the cosine of the second thing, 2 pi alpha, or 2 alpha pi, same thing, plus the cosine of the first thing, alpha phi, times the sine of the second thing, which is 2 pi alpha. All right, 2 pi alpha. Okay, all right, so I'm done with this. Okay, so does this help us? Well, I don't know. Let's see. Sine alpha phi, and here's sine alpha phi, and there's no more sine alpha phi's. This is sine alpha 2 pi, cosine alpha phi, cosine something. So basically, this has to equal this. In math, how would I make this equal this? Well, obviously, this is not helpful because I would have to make this equal to 1, and I would have to make this whole thing equal to 0. Oh, but wait a minute. This does equal 1. Cosine of 2 pi, so when you do the unit circle in trigonometry, right? Cosine of 2 pi, is cosine of 0 equals 1, right? And cosine of 2 pi is also equal to 1. So this actually does equal 1 as long as alpha is a whole number. Like, actually, it doesn't even have to be a whole number. It could just be an integer. So if alpha is 1, then cosine of 2 pi is 1. What if alpha is 2? If alpha is 2, cosine of 2 times 2 pi is 4 pi. Cosine of 4 pi is just 2 times around. See? That's still cosine equals 1. What if alpha is 3? Cosine of 6 pi. That's still the cosine is of 6 pi equals 1. What if alpha is 0? Well, the cosine of 0 also equals 1. What if alpha is negative 1? If alpha is negative 1, we're dealing with the cosine of negative 2 pi. That is just backwards. And we're still at the same spot right here. This still equals 1. So alpha just needs to be an integer, and this will be true. But what about this? How can I get this whole thing to be 0? Oh, wait a minute. This whole thing does equal 0 if the sine of 2 pi is there. Because on the unit circle, the sine of this position here, the sine is the y-coordinate, remember, is 0. So sine of 0 is 0. Sine of one time around, 2 pi, sine of 2 pi is also 0. Sine of negative 2 pi, negative 2 pi, sine of negative 2 pi is also 0. Sine of 4 pi, 2 times around, is 0. Sine of 6 pi, 3 times around, 1, 2, 3. That is also 0. We end up here all the time as long as alpha is an integer. All right? Alpha has to be an integer. So if this part is 0, we don't even think about this part because anything times 0 is 0, right? But now, what is this about alpha having to be an integer? What is that about? Let's verify that. What if alpha were equal to 1/2, right? Then for this little thing which needs to equal 1, the cosine of 2 pi, the cosine of 2 pi times 1/2, the cosine of all this stuff is the cosine of pi. Now the cosine of pi would be equal to, now pi is right here. This is pi. Cosine of pi is equal to negative 1. So that would be a negative sine alpha phi, which is not the same as sine alpha phi. So you cannot have alpha equal to 1/2. In fact, you cannot have alpha equal to anything except for an integer. 0, 1, negative 1, negative 2. All right, so that is how you show that alpha has to be an integer. So you go like this. You go, all right, so therefore, cosine pi, 2 pi alpha must equal 1. And sine 2 pi alpha must equal 0. In order for this equation to be true, in order for this equal sign to be true, these two have to be true. And this is only true, and this is true only for alpha equals, this is a little e for is a member of, the integers. You know, there are many different ways to express this. You can just say alpha is an integer, or alpha equals 0 plus or minus 1 plus or minus 2, blah, 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 right? So that is how you figure it out.